is electromotive force, EMF. So this is the voltage induced in a coil of wire due to Faraday's law. In this simulation, you will do the voltage measured in the system is the EMF. Okay? So first of all, you just need to know that when you create a induced EMF, you create a voltage. Okay? And that's what it's called. It's called EMF, electromotive force, but it's a voltage. Okay? The second thing you need to know is something called magnetic flux. So this is the amount of magnetic field passing through a coil of wire. This number is constant when the magnet's at rest, but it changes when the magnet changes. When the magnet moves, then you change the flux. Okay, so directions. Using an online simulation, you'll test several different variables to see what does and does not affect the induced EMF in a circuit. When you first open the simulation, make sure to check the box or field lines for the voltmeter. This will make it easier to answer the questions. For each question, perform the task with the simulation, then write what you observe about the induced EMF voltage. Talk about both the size and the direction of the voltage change. So how quickly the magnet moves, the time it takes to insert it or remove it. Experiment with insert the magnet quickly versus slowly. And then the pole of the magnet, insert it to two different poles. So what you'll do on the lab is you'll turn the voltmeter on. I would also turn the field lines on so you can see what's going on here. And what you're going to do is you're going to insert the magnet and remove the magnet. Okay? And so the first one wants to know how quickly you do it. So do it once when you insert it slowly. And what you can do is you can watch the voltage up here, and you can watch how the voltage changes as I insert it slowly. Same thing when I remove it slowly. That will actually help with that same one when you enter or remove it. So what does removing it slowly do? Okay? Then do it quickly. So make sure you keep in mind the direction it's moving and the size of the movement. Okay? How much does it change and what direction does it change? Because the direction is going to matter. Obviously, if it was the same for everything, you would just get a voltage change. You wouldn't get a negative voltage or a positive voltage, but you do get negative or positive voltages. So that's going to matter. Okay? So go ahead and get started on the lab when you're ready for it. Okay, there are several things you're going to test. You're going to test the speed of moving the magnet. You're going to test the pole of the magnet. You're going to test inserting versus removing the magnet. You're going to testing moving the magnet parallel to the coil. So that's going to be not putting the magnet into the coil, but putting the magnet next to the coil. Okay? And then you're going to test the number of loops. And to do the number of loops, you're just going to click on this one where you have a second loop of wire that has fewer coils. And you're going to see what happens when you insert into that one or when you insert it into this one. You're right there?
I'm sorry.
Okay. If you're wondering how to do the pole, you can switch the pole this way. Okay. All right. So get working on the lab when you're done with the practice, and that's what you should work on next. Both need to be completed for next period. So both the lab and the practice should be done for next period. It should not be a problem, but I do want to make sure to just be clear on that. Okay? So get working there. Again, make sure you're looking for two things. You're looking for the size of the voltage change and the direction of the voltage change.
Thrown up on me in my car and we still were watching Raising Cane's.
You would have paid for it.
I would have paid for that. I'm the one who initiated the date. That's 2023. Come on.
I've never had.
Are you trying to get me to the light?
I need a.
Try and get news to look at keys.
It's
like
Yeah, I mean, you can ask in student services.
Could you imagine, like, no shielding, you got shot straight through? Yeah, you're done.
Wait, what's the like the slow what you said? It goes so fast. You even need to count. Have you ever said slow?
Yeah. I want to see this. There is shit off. I don't have any of it.
Oh, this is the E.
Did you ever I don't want to rip
So what did you need? Someone
you say, like, just
Yeah, what was the
magnetism?
So why do you think that's?
We're making force.
Yeah.
And that's all you need for them. Is opposite. So their opposite poles cause the voltage to go opposite directions.
Yeah.
That's all you need. You don't need to know like why is positive, like why is the north pole is negative and the
Eli,
south.
like,
He's killing his plane right now.
You just need to know that.
It just falls instantly.
Somewhere along. Like, it might even look like it's falling. Did you see the
Yep, if you have any questions, let me know. If you're having trouble explaining something or need help explaining something. So, pull it out. So see how it still makes it move, even though, but it's going to make it move. So pull it, so move parallel as opposed to.
I know, it's so funny. There's no longer a C.
Wait, it's that precise? Is
Inserting versus removing.